All right, Unit 6, retake. Here we go. Solving the system. Since both of these are equal to y, we're going to make them equal to each other. And then we're going to, actually, you know what? There we go. We're going to go ahead and add 2x to both sides to zero that out. And we're going to add 7 to both sides to zero that out. So that'll be negative 2x squared plus 6x plus 8 equals 0. And then you're going to solve this. You can use the quadratic formula or you can graph it. So x equals, and don't forget, if we're going to use the quadratic formula, this will be a, this will be b, this will be c. So that'll be negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And once you solve that, you have to do it 2 separate times, once for plus, once for minus. Once you do that, you should get x equals 4 and x equals negative 1. Now, I know normally we would stop, but we have 2 variables that we have to consider. Okay, so y and x. So we're going to have to plug this back in. I'm going to use this equation because it's simpler. That's the only reason I'm using it. I could use either one. So I'm plugging in the 4 that I just got for x. That's going to get me negative 15. I'm going to do it again, and I'm going to plug in the negative 1 that I just got, and that's going to get me negative 5. So our 2 solutions are going to be 4, negative 15, and negative 1, negative 5. Number 2. Go ahead and try number 2. Number 3, draw a number line to represent the solution set. The first thing we need to do is change this to an equation like that. Get everything to one side to get 0 on the other side. That's already done. And now we're going to solve for x. You can solve by graphing, by factoring, or by using the quadratic formula. I'm going to do quadratic formula. Again, this would be a, which would be 1. This would be b. This would be c. So that would be negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. Once we do that, we should get these solutions, negative 6 and 1. So x equals 1, x equals negative 6. All right, and since this is an inequality, we're going to do this on a number line to graph it to show the solution set. Okay, so I'm going to keep this. Alrighty, so we're going to graph 1, and we're going to graph negative 6, and we know it's an open point because this is greater than, not greater than or equal to. So now we need to check and see which interval works. So let's check this interval first. Oops. So instead of using an x, I'm going to use a number that is less than negative 6. Okay, and I'm going to have to do this 3 times. All right, so the first number I want to try again is less than negative 6, so I'll just use negative 10. This is going to be a true statement. All right, now if we use 0, we can see here that 0 squared is 0, plus 5 times 0, which is also 0. That's, and a minus 6 is negative 6. Negative 6 is not greater than 0, so that's false. And then here, we're just going to use, I don't know, 2, something like that. And that would also be a true statement. So the only ones that were true would be this area, and then this interval over here as well. And there you go. Another way that we could write the solution would be that x is less than -6 and x is greater than 1. Go ahead and try number 4. All right, number 5, write the system of equations shown below. So we can use the vertex of this parabola. I'm not going to do that. Okay. So for this parabola, I'm not going to use the vertex just because for the next problem, it doesn't use the vertex. I'm going to use the y and the x-intercepts right here and right here. Okay, so that would be y equals, so we have what, -3 and +1. So x plus 3 and x minus 1. All right, and that would, once you use FOIL, that would be x squared plus 2x minus 3. And then for the linear equation, it'll be this one right here. All right, we see that the y-intercept b is 1, and then the slope is up 2 over 1, up 2 over 1, up 2 over 1. So the slope is 2 over 1, or just 2. So that'll be y equals mx plus b. All right, there you go. And go ahead and try number 6. Number 7, what is the y value of the solution? So we're going to do the same thing we kind of did for number 1, except this one's going to be a little bit different because both of these do not equal y. So first, let's make them, you can make them both equal y. So for this one, I could just take away 6x from both sides. And so that would give me y equals -6x minus 10. Okay, and now we can do what we did for number 1. So that would be x squared minus 20x plus 39 equals -6x minus 10. All right, and then we're going to add 6x to both sides and add 10 to both sides, and that'll zero those two out. Let me add 10 to both sides like that. Okay. So then that'll leave us with x squared minus 14x plus 49 equals 0. So now some of you might be able to look at that and tell that that's a perfect square trinomial, but if not, that's fine. Just use the quadratic formula. So that'll be -b plus or minus the square root of b squared minus 4 times a times c over 2 times a. And when you do that, you should get x equals 7. You should only get one solution. Even when you do it for plus and minus, you should still get x equals 7. You'll get it twice, but it's still just x equals 7. This question is asking for the y value, so we're going to take this 7, and I'm going to plug it back in up here. So y equals -6 times 7 minus 10. So I'm just plugging it back in. And typically I would tell you to plug it into the original one to avoid any mistakes, but yeah. So that's going to be -52 for the y value. And if you plugged it into the quadratic, the pink one right here, it would also give you -52. Go ahead and try number 8. Number 9, we want the solution set. So we have another inequality, so I know that this is going to require a number line. Let me get that ready. First thing I need to do is get this equal to 0. I'm sorry, make this an equation. And then get it equal to 0. So I'm going to subtract 15 from both sides like that. Now I'm going to solve for x. Again, you could factor this. This is definitely factorable to get the solutions. Or you can just use the quadratic formula like I'm doing now. And if you use either method, you should get the same solutions, -5 and 3. Since this says less than or equal to, it's going to be a closed point. So color that point in and put it on your graph. All right, now we're going to check each interval. So we got here. We need something that's less than -5, so I will use -10. squared. So I'm just plugging this back into the original inequality to see if it's true or false. All right, so negative 10 squared is 100. 100 minus 20 is 80. Is 80 less than 15? Nah, so that's false. So we're not going to shade that area. Let's check the next area. I'm going to use 0 because 0 is easy to work with, and it's also between those two numbers. All right, 0 squared is 0, plus 2 times 0 is also 0. 0 is less than or equal to 15, so that's true. So we're going to shade this area because that is true. And then last but not least, we have something greater than 3. I'll just use 10. All right, so 100 plus 20 is 120. That's not less than 15, so that's false. So don't shade that area there. All right, so there you go. There's your number line. So this would translate to, as an inequality, x is greater than negative 5, but it's also less than 3. Oh, or equal to. All right, go ahead and try number 10. All right, we're going to consider these points, and we're going to find the regression equation. Sorry, I had a brain fart. All right, so let's go to here. We're going to start, thank you. We're going to start a new list. Okay, we'll put an X, and we're going to put a Y. Great. Now we're going to list all of our X values from that problem. So we have 1, 3, nope, 2, sorry, and 4. Then the Y values would be 3, 8, and 6. And then we're going to add a data and statistics. Okay, document. All right, so there you go. Make sure you put X for the X-axis, Y for the Y-axis. And now we're going to analyze this graph with a regression and with a quadratic. And there you go. There's the equation right there. So that would be Y equals negative 2x squared plus 11x minus 6. Go ahead and try number 12. Number 13 is the same thing. So this will be our X, this will be our Y. All right, so all of our X's for number 13 are 0, 1, 3. And please pay attention because I'm not going to do this again after this problem. I'm just going to give you the answers so you can practice on your own. All right, so now we're going to, oh, my bad. We're going to add a data statistics page here, and that'll be your x-axis, of course. This will be your y-axis. And we're going to analyze the graph. So go to menu, analyze. We want the quadratic regression. Boom. And there's your equation right there. So that'll be y equals negative 4x squared plus 11x plus 5. All right. Try number 14. Number 15, again, this will be our x, this will be our y. Go through all those same steps on your calculator. You should get y equals negative 6.9x squared plus 103.8x minus 11.8. So you can pause the video here and try to get the same thing to make sure you can. Number 16, try it yourself. Number 17, again, this is going to be x, this is y, and you should get y equals x squared plus x. So try that to make sure you get the same answer. Now try number 18 on your own. Again, this will be x, this will be y. All right, number 19, if you read through this problem, you'll see that we want the car, the data for the car. We do not want the data for the truck. So this is going to be our x, car is going to be our y. And for this, you should get y equals 0.047x squared plus 2.207x plus 0.214 because we're rounding to the nearest thousands. Thousands is 3 decimal places. Try that on your own to see if you get the same thing. All right, now try number 20. All right, that's it.